Good morning, everyone. Um, Welcome to OCP breakout session. So, power management and monitoring is the biggest concern in the IT infrastructure. As you look at the yesterday's keynotes, everybody is talking about how in IT power would be managed in over the period. So we need to set some future-proof ready model to make sure the power is well strategized for the IT infrastructure. By the way, we know the challenge. Today, I want to introduce the tool called Triton, which is a Redfish-based tool, and I will talk about more in this meeting. I'm Sathish from Samsung Semiconductor India Research, and my co-partner for this project is Deepti Shukla. She was unable to join today. Here's the agenda. So we wanted to share what is Triton, how this is going to be benefits to you, and the typical overall block diagram of how Triton works, and how we can deploy, get started with Triton, and we wanted to share about that open source contributions, and finally call to action. What is Triton? Triton is the open source software based out of Redfish standard. It's built on the Python language, which is a predominant language being used in IT industry. So with the Triton, we can manage multiple hardwares remotely in the scale of more numbers. And it provides a set of simplified APIs that could be used to manage power and monitor the power efficiently in your IT infrastructure. And we wanted to make it more simplified APIs, Python APIs that can be called on your basic automations that can be created workflows. Finally, this could be used to validate the Redfish API based on the DMTF Redfish standard. So what Triton, how it's going to be benefits to you. So managing the servers in terms of how to build the power strategy, what is required to make your power consumption of IT infra is something you can use this tool effectively, which would give you what exactly required to make your IT infra. And as I said, we can able to build automation workflows to control remotely in the scale of multiple servers. And of course, we can use to validate the Redfish APIs by running this tool. Some of the key capabilities of Triton here is, it's a APIs which helps you to provide power consumption report, and we could able to validate the Redfish URLs, and we could able to find the response of the Redfish, Redfish calls, and which gives you a configuration where you can configure multiple servers, information, and you can able to customize your exact way to look at the Triton report, and which provides an extensive HTML and Excel based report that can be used to generate more insights. And again, we have created a monitoring utilities which would take care of monitoring your infrastructure while you are in sleep. Let me move on to the overall block diagram of how does this Triton works. So Triton actually starts from the executor machine, which probably a Linux-based server. You can use it to trigger this Triton software. So the moment you trigger the software, it actually takes the DMTF Redfish specification and the schema information remotely from dmtf.org. Again, it's optional stage. You can even skip if you already downloaded those specification in your local repository. Once you have downloaded, the next stage is the APIs. That's exactly what we have built based out of Triton, which reads the configurations of set of servers and try to run it over the network, and it try to collect that information from the system under test. And eventually, this will be given to the validation and modules. Or we have created a couple of modules, wrapper modules that parse the input from your Redfish API and try to generate a report which could be used for sharing and even finding the insights what's exactly happening in your infra. So that same input would be given back to the executor machine, which could be leveraged for future purposes. This has been built on Python 3.8, and of course it uses the Open API and as well as the Redfish APIs. Here's the way we can install the Triton on your system. So again, this has been open sourced under OpenMPDK GitHub, which is a Samsung open source hub. So installation is very simple. We have three-step process. You can just run the Python install.requirement.txt, which should capable to install in all the prerequisites in an one shot. And there is a config file. It's a very simplified config file where you can feed all your BMC details, which should be the config for your Triton to run. And finally, just invoke the example scripts what we have built already, which would create the necessary output for you. So, which already we have been tested this one with Ubuntu 18, 20, and 22 OSs. I think this would be used, I mean, you can use it for any Linux-based operating system. So it's a very simple directory structure. We have config, examples, and libraries. So these three, which gives this overall Triton modules. And again, the requirement text, which talks about all the necessary modules to be loaded for the installation. This is a sample configuration file where you can feed the BMC information with username, password. You can add a number of one, and even you can have scale of a number of BMC IPs here. And crucially, I mean, there are a couple of URL information, which is again a standard way to collect the Open API for the Redfish. As of now, it's a DMTF org website. And we have the key thing is the threshold, power threshold value and time interval. This would be used to measure and monitor, which eventually I'll be talking into the successive slides, how this value is going to be useful on your infrastructure. Here's the validation report. We just run it on any server or in a number of servers. This would give you a report of the set of inventory what you have, and which will give the health of your system. How does it behaves, and what are the inventories exist in your system. So we just used it to make sure, yeah, your system is can be deployed into the Triton tool with the help of this report. The next interesting thing what we have done is the power monitoring utility. So what basically it does, right, this is exactly today, we want to know what is my overall power consumption of my infra, or what exactly, how much I load needed for setting up my, or how I can plan it eventually in future. So we created a module which takes care of running your, collecting the power consumption in watts in a periodic interval of multiple servers, which you have fed into the config.json file, and which will give you the view of how this being consumed over the period. So to run this one, it's very simple. As I said, configure the config underscore redfish.json file, then just run the power underscore data.py, which would take care of collecting all the information and which gives you to show the value. This is the raw output which is being generated by this tool. So you can see that, again, due to the space constraint, I had put 3 servers here, but you can have a number of servers as and when how many infrastructure servers you have in your IT. The next aspect is the consumption analysis. So this is one typical challenge we had in our infra. So we have a rack space. Every rack we had a power limit. So what would happen is, in case in the sudden burst of peak workload, we may end up with a power tripping because of the over power consumption of the server. So we just wanted to understand what's happening and how to avoid that. So we wanted to know that which server is taking more power in certain time. So that's something we have built this utility to bring it up to understand more and more about that. So we can set some threshold of this is exactly what my power for this server. So if any server which takes more than that power, which should be highlighted in the report, uh, so that I can understand, okay, these are the servers which actually take something, so that I can balance my load across racks, so it won't impact any power problem. So to do that, it's again a straightforward uh, config the JSON. You need to provide your BMC details. Just run the test hardware management, which will take care of creating the HTML report based on this one. As of now, which creates the HTML report. Eventually, we wanted to add it as an email notification, so that it would be notified to you. Here's the sample report where we have collected for the threshold of 500 watts. So, so this report would talk about whichever server takes more than 500 watt would be highlighted here, so that we know that what exactly which servers to be positioned in according to make sure there is no overpower consumption in the given rack. These are the key features what Triton provides as of now. So which does the URL validation and which does the JSON schema. And we added the put and patch support. Of course, the get support as well, it's there. And we wanted to make sure it's a one-click install so that anybody can install it right away and start consuming it. Again, it does the hardware management and the output report. So we started this, internal project, and we found that this would be a crucial project for even the open source community. So we made it to open source. The first release we did in last year, 2022, December, where we just added the all Redfish API URLs and get inventory of most of your hardware components and try to generate HTML report, which I had shown in the validation report previously. The last release we had it in July, where we basically targeted for power management and monitoring APIs. So which actually create the HTML report for your threshold, and which even gives the Excel report for your utilization over the period, so that you can build more and more graphs or insights out of it. Here's the summary. It's a platform agnostic solution. As long as your hardware supports Redfish API, you can deploy this software right away in your environment. Again, which provides a lot of hardware management and monitoring utilities. It could be used for any data center, OEM and ODMs. So we just concentrated more on power management to make sure that we can make the infrastructure is future-proof. And again, it's an open source solution, which is open for anybody to consume it. So you can reach out to me and Deepti for any support. And we wanted to highlight the contribution. Thank you for our contributions, Arun and Nidhi, and we want to thank our leadership team who support us to build this tool over the period. Is the call to action. So since it's open source, it's open for external contributions and feedback. It's already available in Open MPDK GitHub. And we wanted to add more users and adapt more modern use cases, which primarily we are talking about in the scale of servers. We had a couple of future plans. So the power capping using the tool is something we wanted to add it right away. So to set the limit in watts, so that in any server goes beyond that limit would be at least notified, and we need to make sure we can control the power utilization of the server. Also, we wanted to add some dynamic power management support. So based on the workload, we can able to provide the power capping. For example, in the daytime, you can set for 800 watts. On the night time, you can set it for 400 watts, so that the power would be planned properly, so effectively we can manage it in the IT infra. So the SMTP integration for the email notification, that's something we wanted to add it. And again, we can build a lot of graphs out of it, so we are exploring a couple of pivoting options to explore graph so that you can use it for any reference or you can use it for use it for any insights. And subsequently, we wanted to add the CXL device support since many devices are emerging. We wanted to add this inventory of CXL devices. And again, we are looking forward with the DMTF team to inclusion in their DMTF repository. Yeah, thank you.
We have time for questions. Any questions? There are 2 mics there.
A question. In the early slide, you had OpenAPI listed. How are you using OpenAPI?
Yeah, so OpenAPI, so from the JSON reference, so we have an OpenAPI Python module, so we can read that out, and we are building the URLs and the JSON schema with the help of that APIs. So that's the reason we wanted to download it locally, and we are building just referring that these are the APIs to be used for collecting such details. For example, the power control needs to be used at OpenAPI JSON schema.
So you mentioned you have it on an open source repository. So can one file GitHub issues against it?
Sorry, John?
If someone has a question or an issue, is the GitHub allowed for issues?
Yes, it's allowed. Yeah, okay. It's available.
So here's my first question. The original Redfish spec used power and thermal resources, and since then it's moved to power subsystem and thermal subsystem. Do you know which one you're using right now?
So as of now, we are using the chassis power control power.
Okay.
We are collecting from there.
Okay.
Okay, any more questions? Okay, if not, then let's thank our speaker, Sathish here. Thank you.
Thank you.